Good afternoon. I am Pathve, Assistant Professor in Mulji Jeta College, Jalgaon. I am going to talk about the mathematics in ancient India. Mathematics on the Indian subcontinent has a rich and long history going back over 5,000 years and thrived for centuries before advances were made in Europe. Its influence spreads to China, South Asia, and the Middle East and Europe. Apart from introducing the concept of zero, Indian mathematician made seminal contribution to the study of geometry, arithmetic, binary mathematics, and the notion of negative numbers, algebra, trigonometry, and calculus among the areas. The decimal place value system that is employed worldwide today was first developed in India. Classical period that was 4th to 16th century. This period is often known as the golden age of Indian mathematics. This period saw mathematicians such as Aryabhata, Varahamihira, Brahmagupta, Bhaskara I, Mahavira, Bhaskara II, and Madhva of Sangamagrama and Nilkanta Somayaji give broader and clear shape to many branches of mathematics. So first we see what is the concept of zero. So concept of zero was discovered by an anonymous Indian. The concept of zero in India holds significant historical and mathematical importance. The numeral 0 as we understand it today is an integral part of the decimal number system and it was developed in ancient India. So first earlier development, India's earliest recorded use a decimal system and 0 can be traced back to the Indus Valley civilization which existed around 2500 to 1500 before Common Era. However, the concept of zero as a number with its own value and significance started to evolve later. Brahmagupta's contributions, one of the key figures in the development of the concept of zero in India was the mathematician Brahmagupta, who lived around 598 to 668 Common Era. He made significant contribution to the understanding of zero. He defined zero as a number and discussed its mathematical properties. He introduced rules for arithmetic operations involving zero, such as the addition, subtraction, multiplication, and division of zero, which are now fundamental concepts in mathematics. Aryabhata's contribution. Aryabhata, an Indian mathematician and astronomer who lived around 476 to 550 Common Era, also played a role in zero development. In his work, Aryabhatta used a symbol to represent zero and recognize its importance in mathematical calculations. The concept of zero and the decimal numeral system with its place value notation spread from India to Islamic world. Islamic scholar like A.L. Khwarizmi further developed his ideas and they eventually made their ways to Europe during the Middle Age. And importance in the modern mathematics, zero is now considered one of the most fundamental concepts in mathematics. It serves as a placeholder in a decimal system, enabling us to represent numbers of varying magnitudes efficiently. It is also crucial in algebra, calculus, and many other branches of mathematics. The concept of zero in India has a long and rich history, with mathematicians like Brahmagupta and Aryabhatta making significant contribution to its development. So next concept is pi. The concept of pi, which represents the mathematical constant approximately equal to 3.14159, has a long history in India. As well as in other ancient civilizations, in India, pi was known and calculated by mathematicians and astronomers in various ways over the centuries. So first ancient texts. So Indian mathematicians and astronomers in ancient times made references to pi in their text. For example, the Sulba Sutra, which are a collection of ancient Indian texts dealing with geometry and constructions, included approximations of the value of pi. Also contribution of Aryabhatta. Aryabhatta, an Indian mathematician and astronomer who lived around 476 to 550 Common Era calculated an approximate value of pi as 3.1416 in his work Aryabhata. He used a geometric method to estimate pi, which was later refined by other Indian mathematicians. Also contribution of Bhaskara first. So Bhaskara first, who lived in the 7th century, also provided an approximation of pi in his work Mahabhaskariya. He used a different method involving a polygon with 384 sides to estimate pi more accurately. Also contribution of Madhva. The mathematician Madhva of Sangamagrama, a prominent figure of this school, developed a series expansions for trigonometric functions including pi. Madhva's work predicted European developments in calculus and infinite series by several centuries. It's important to note that while Indian mathematicians made notable contribution to the understanding and approximation of pi, the concept of pi and its accurate calculation were also pursued in various other ancient civilizations such as Babylon, Egypt, and Greece. The approximate value of pi is 22 divided by 7 or 3.1415926539. Now next, the number system. So in India has a rich history of number system with significant contributions to the development of various numeral systems. One of the most influential contribution in the decimal numeral system, which is now the most widely used number system globally. So first one, Indus Valley Civilization. The earliest known evidence of a numerical system in the Indian subcontinent can be traced back to the Indus Valley Civilization. Archaeologists' findings indicate the use of symbols for counting and recording quantities. Brahmi numerals. The Brahmi script dating back to around the 3rd century played a significant role in the development of numeral system in India. It had symbols for numbers, and these symbols are considered some of the earliest written representation of numerical values in India. Kharosthi numeral system. The Kharosthi numeral system was a propositional decimal system similar to the more widely known Indian numerical system. It used symbols to represent numbers, and the position of a symbol in a number determined its value, just as in the Indian numeral system. The Kharosthi numeral system included various lines and curves to represent different numbers. They had symbols for numbers from 1 to 9 and a symbol for 0, making it a decimal system. The Kharosthi script and numerals have been found on inscriptions, coins, and other ancient artifacts. So what is decimal system? The most significant contribution of India to the world of mathematics is the decimal numeral system. This system is based on the number 10 and use 10 symbols 0 to 9 to represent all possible numbers. The concept of 0 as a placeholder and as a number itself was developed in India. The decimal system with its place value notation simplifies arithmetic calculation and is the foundation of modern mathematics. So invention of 0. The concept of 0 as both a placeholder and a number is attributed to Indian mathematician. The use of 0 revolutionized mathematics and made complex calculations much more manageable. The decimal system with 0 traveled from India to various parts of the world, including the Islamic world and eventually Europe. Islamic scholar already we see Al-Khwarizmi plays a crucial role in transmitting Indian mathematical knowledge to the West, where it becomes the basis for modern mathematics. Other numeral system. India also had regional numeral system. Example, the Gupta numeral system was used in the Gupta Empire around 4 to 6th century. These systems had unique symbols for numbers but were gradually replaced by the more efficient decimal system. In summary, India's contribution to the development of the decimal numeral system with zero is one of its most significant intellectual achievements. This system has had a profound and lasting impact on mathematics and has become an integral part of global numerical and mathematical notations. So, Pythagoras theorem. The Pythagoras theorem, which stated that in a right angle triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the other two sides, is a fundamental theorem in geometry. While the theorem is named after a ancient Greek mathematician Pythagoras, similar geometric principles were known and applied in various cultures including India. Long before Pythagoras' time, in India, there is evidence to suggest that knowledge of geometric principles related to the Pythagorean theorem was presented in ancient times. First one, Sulba Sutra. The Sulba Sutra are a collection of ancient Indian texts that date back to around 800 before the Common Era to 200 before the Common Era. These texts primarily deal with geometry and provide rules for the construction of altars for religious ceremonies. Some of these rules involve right angle triangles and the application of what we now recognize as a Pythagorean theorem. While they may not state the theorem explicitly, they demonstrate an understanding of the relationship between the sides of the right angle triangles. Next contribution, Budhana and Apstamba. Budhana, an ancient Indian mathematics, and Apstamba, a sage and mathematician. They provided geometric methods for constructing right angle and calculating diagonal measurements that align with the principles of the Pythagorean theorem. Also contribution of Aryabhata. In his work Aryabhata, he discussed the relationship between the length of chord and radii of circles, which are related to the Pythagorean theorem. While these Indian mathematicians and texts demonstrated knowledge of geometric principles related to the Pythagorean theorem, it's important to note that the theorem is named after Pythagoras because he is traditionally credited with providing the first formal proof of the theorem in ancient Greece. Vedic mathematics. Vedic mathematics is a system of mathematics that claims to be based on the ancient Indian scriptures known as the Vedas. It is often attributed to a scholar named Swami Bharati Krishna Tripathi, who published a book titled Vedic Mathematics in 1965, where he introduced and popularized this system. However, it's important to note that the legitimacy and historical accuracy of Vedic mathematics as a distinct mathematical system is a topic of debate among mathematicians and scholars. Some key features and claims associated with Vedic mathematics. First one, sutras. Vedic mathematics is said to be based on a set of 16 sutras and 13 upasutras extracted from the Vedas. These sutras are claimed to provide efficient and unconventional methods for performing various mathematical operations such as addition, subtraction, multiplication, division, square roots, and cube roots. Second one, mental calculation. Vedic mathematics emphasizes mental calculation and claims to offer techniques that allow individuals to perform complex mathematical computations in their heads quickly. Proponents of Vedic mathematics argue that these techniques can lead to faster and more efficient calculations compared to traditional methods. Next one, general applicability. Vedic mathematics is said to be applicable to a wide range of mathematical problems, and it is not limited to specific areas of mathematics. Proponents claim that it can be used in various fields including arithmetic, algebra, geometry, and calculus. While Vedic mathematics has gained popularity in some educational circles and has been the subject of books and workshops, it has also faced criticism and skepticism from mainstream mathematicians and educators. Critics argue that many of the techniques promoted as a Vedic mathematics are not significantly different from or more efficient than established mathematical methods. So what is the educational use of Vedic mathematics? So Vedic mathematics has been introduced as a teaching tool in some school and educational programs. It can help students develop mental math skill and improve their speed and accuracy in calculations. In summary, Vedic mathematics is a system of mathematical techniques and methods that claim to be based on ancient Indian scriptures. While it has gained some popularity and is promoted as a way to improve mental calculation skills. Next Indian mathematician is Aryabhata. So Aryabhata was an ancient Indian mathematics and astronomer who lived in the late 5th century. He is one of the most significant and influential mathematician and scientist in the history of India. Some key contribution and information about Aryabhata. Aryabhata, which is written by Aryabhata, is the best known for his major work, the Aryabhata, a Sanskrit text consisting of 121 verses. These works covers a wide range of topics in mathematics and astronomy. In the Aryabhata introduced innovative mathematical concepts and techniques. Also, Aryabhata's contribution in pi. Aryabhata approximated the value of pi as 3.1416, which was significant improvement over earlier estimates. His work provided a more accurate understanding of the ratio of the circumference of a circle to its diameter. Trigonometry. Aryabhata made significant contributions to trigonometry. He introduced trigonometric concepts and the sine functions, which he referred to as Jaya. His trigonometric tables and methods laid the foundation for further developments in Indian mathematics. Astronomy. Aryabhata works in astronomy included calculations related to the positions of planets, the lunar eclipse, and the solar eclipse. He proposed a heliocentric model of the solar system in which he correctly stated that the earth revolves around the sun. This heliocentric idea was well ahead of its time and predated similar ideas in Europe by many centuries. The number system also Aryabhata contributed in number system. So Aryabhata made contribution to the Indian number system, including the use of a place value notation system and the concept of zero as a placeholder. So it's important to note that Aryabhata is often referred to as Aryabhata 1, as there were other mathematicians and astronomers with the same or similar names who lived in later centuries. Aryabhata's contribution to mathematics, astronomy, and trigonometry remains significant, and his work is considered a cornerstone of ancient Indian science and mathematics. Aryabhata was the first of the significant mathematician astronomer from the classical age of Indian mathematics and Indian astronomy. he treated mathematics as a different discipline. Next mathematician is Mahavira. Mahavira, also known as Mahavira or Mahavira II, was a renowned mathematician and Jain philosopher who lived in India in 9th century. He made significant contributions to the field of mathematics, particularly in the area of number theory. Some key contributions: Ganita Sara Sangraha. Mahavira wrote Ganita Sahara Sangraha. So Mahavira is best known for his work Ganita Sahara Sangraha, which translates to Compendium of the Essence of Mathematics. This text is a comprehensive treatise on mathematics and is considered one of the most important works on Indian mathematics. The number system. So also Mahavira also contribution in number theory. Much of Mahavira's work focused on number theory, including the study of prime numbers, factors, divisibility, and algebraic equations. He made important contributions to understanding the properties of numbers. Also contribution in prime factorization. Mahavira developed a novel method for prime factorization, which involved a systematic procedure for finding the prime factors of a given number. His method was more efficient than earlier techniques and is still studied by mathematicians today. He also made advancement in the study of continued fractions, which are expressions in which a number is represented as an infinite series of fractions. Mahavira works on continued fractions as pioneering and contributed to the broader field of mathematics. So he also Jain philosophy. So in addition to his mathematical contribution, Mahavira was a Jain philosopher and scholar. Mahavira works in mathematics was in harmony with Jain principles of intellectual pursuit and knowledge. Mahavira's Ganita Sahara Sangraha remains an important mathematical text and his contributions to number theory continue to be studied and appreciated by mathematicians and scholars interested in the history of mathematics in India. Next mathematician is Budhana. So Budhana, also known as Budhana Acharya, is an ancient Indian mathematician and scholar known for his significant contributions to mathematics. He is believed to have lived around the 6th century, which is before the Common Era, making him a prominent figure in the history of Indian mathematics. Budhana's work primarily focused on geometry and geometric principles. One of Budhana's most notable contributions is his commentary on the Brahmagupta, which was originally written by renowned Indian mathematician and astronomer Brahmagupta. Budhana commentaries provided valuable insights and explanation for the mathematical concepts and principles presented in the Brahmagupta. In his commentary, Budhana elaborated on various mathematical topics including arithmetic, algebra, and geometry. He expanded upon the geometric concepts and theorems found in Brahmagupta's work, which included ideas related to geometry, algebra, and so on. So first one, geometry. So Budhana commentator covered various aspects of geometry including the properties of triangles, circles, and other geometric shapes. He explained the principles of constructing altars and geometric figures. Next one, algebra. So Budhana contributed to the understanding of algebraic concepts and equations. His commentary contained explanation of algebraic expressions and equations, demonstrating his mathematical prowess. Budhana's work, along with other ancient Indian mathematical texts and commentaries, play a crucial role in the development and transmissions of mathematical knowledge in ancient India. His contribution, as well as those of other Indian mathematicians and scholars, helped shape the foundation of Indian mathematics and laid the groundwork for further advancement in the field. Next one, Bhaskaracharya. Bhaskaracharya, also known as Bhaskara II or Bhaskaracharya II, was a renowned Indian mathematician and astronomer who lived in the 12th century. He has one of the most significant mathematicians and scholars of the medieval period in India, and they also contributes in mathematics. So Bhaskaracharya made important contributions to mathematics, particularly in the area of algebra, arithmetic, and calculus. His work Lilavati is one of his most famous mathematical treatises. In his book, he covered various mathematical topics including number theory, geometry, and solutions to mathematical problems. Second one, astronomer. Bhaskaracharya was also an accomplished astronomer. He wrote the astronomical treatise known as the Siddhanta Shiromani. This work is divided into 4 sections. Lilavati is included arithmetic and geometry, and Bijganita, which is algebra, and Garaha Ganita, mathematics of the planets, and Goldhaya, spherical trigonometry. In the Gahanita section, he made significant contributions to understanding planetary motion and eclipses. Bijganita. Bhaskaracharya's Bijganita is a comprehensive work on algebra. It covers topics like solving equations, indeterminate equations, and algebraic methods for finding square roots. He also contribution in calendar reform. Bhaskaracharya proposed calendar reform and made adjustment to the Indian calendar system. His insight to the calculation of leap years and the adjustment of months contributed to the accuracy of Indian calendars. Bhaskaracharya works, especially Lilavati and Siddhanta Shiromani, remains important sources for understanding the mathematical and astronomical knowledge of his era. Next one, Varahamihira. Varahamihira is also known simply as Varaha, was an ancient Indian scholar and polymath who lived during the 6th century. He made significant contribution to various fields of knowledge, including astronomy, mathematics, astrology, and meteorology. So first one, astronomy and astrology. Varaha is best known for his astronomical and astrological works. His most famous work, Brihat Samhita, the Great Compilation, is a comprehensive treatise that covers a wide range of topics, including astronomy, astrology, mathematics, architecture, and more. It provided valuable information about planetary positions, ellipses, and other celestial phenomena. Varahamihira made contribution to mathematics, particularly in the content of astronomy and mathematical calculations related to calendars. He was skilled in the use of numbers and mathematical techniques for astronomical and astrological predictions. Meteorology. Varahamihira also wrote about meteorology in Brihat Samhita, offering insight into weather patterns, forecasting, and related phenomena. His work included observations about natural disasters and atmospheric conditions. He also contributions in calendar reform. He proposed reform to the Indian calendar system to make it more accurate. His recommendations influenced the development of Indian calendars and their adjustment for leap years. Jyotisha. He also contributed in Jyotisha. Varahamihira was a prominent figure in the field of Jyotisha, Indian astrology. He made significant contributions to the study of horoscope, planetary movements, and the interpretation of celestial events. In summary, Varahamihira's Vidhat Samhita remains an important source of information for understanding ancient Indian knowledge system, especially in field of astronomy and astrology. Next Indian mathematician is Brahmagupta. Brahmagupta was an ancient Indian mathematician and astronomer who lived during the 7th century. He was one of the most influential mathematicians of his time, made significant contributions to various branches of mathematics, including algebra, number system, and geometry. Some key aspects of Brahmagupta's life and contributions. Brahmagupta Siddhanta. Brahmagupta is the best known for his mathematical treatise titled Brahmagupta Siddhanta, which translated to the collected treatise of Brahma. This work covers a wide range of mathematical topics and is considered one of the most important mathematical texts from ancient India. Also contribution in algebra. Brahmagupta made significant contributions to algebra. He introduced the concepts of positive and negative numbers including zero and discussed their properties and operations. His work laid the foundation for the systematic study of integers and rational numbers. One of the Brahmagupta's most famous contribution is his treatment of zero as a number with its own mathematical properties. He discussed zero's role as a placeholder in numerical notation and explained rules for arithmetic operations involving zero. Brahmagupta was also an accomplished astronomer. His work included observations of celestial phenomena such as planetary positions, space, and positions of stars and planets. He developed methods for calculating the positions of celestial objects. Brahmagupta made contribution to geometry as well. He studied various geometric shapes and properties, including the area of triangles and cyclic quadrilaterals. His work on geometric theorems and proofs was influential in the field. Also contributed in trigonometry. Brahmagupta was contributed to trigonometry by developing formulas and relationships involving trigonometric functions, particularly for right angle triangles. Next one, Madhva, the Kerala School of Mathematics and Astronomy. The Kerala School of Mathematics and Astronomy, also known as the Kerala School of Astronomy and Mathematics, and was a prominent center for mathematical and astronomical research and scholarship that flourished in the southern India state of Kerala between 14th to 16th century. This school of thought made significant contribution to various fields of mathematics, astronomy, and related sciences. So some key aspects and contributions of Kerala mathematics and astronomy included. So trigonometry. The Kerala school is renowned for its contribution to trigonometry. The mathematicians of this school developed elaborate trigonometric theories and methods for calculating various trigonometric functions. One of their most significant achievements was the discovery of infinite series expansions for trigonometry functions like sine, cosine, and tangent, which predated European developments in calculus. Next, contribution in calculation techniques. The Kerala mathematician developed innovative and efficient calculation techniques for complex mathematical and astronomical problems. These techniques included methods for the rapid calculation of planetary positions, lunar eclipses, and other celestial phenomena. Astronomy. The Kerala school made notable advancement in observational and computational astronomy. They developed models for predicting planetary motions and eclipses and contributed to the understanding of celestial events. Mathematical literatures. The scholars of the Kerala school produces numerous mathematical and astronomical texts. Some of the well-known texts included Yukti Bhasha by Jayastha Deva. Second one is Tantra Sangraha by Nilkantha Somayaji and Karna Padhati by Shankara Virar. Calendars reform also contributed in calendar reforms. The Kerala school played a role in calendar reforms. They made adjustment to the Indian calendar system, taking into account astronomical observations and calculations to ensure the accuracy of calendars and festivals. While the Kerala school was primarily active in Kerala, its ideas and discoveries had a broader influences. They influenced developments in mathematical and astronomical thought in other parts of India and the world. So also connection to earlier mathematics, earlier Indian traditions, the Kerala school built upon earlier Indian mathematical and astronomical traditions, including contributions from scholars like Aryabhata, Brahmagupta, and others, and they expanded upon existing knowledge and developed new methodologies. The Kerala school's achievements in mathematics and astronomy were significant and attracted the attention of scholars and travelers from different parts of the world. Their work in trigonometry in particular was ahead of its time and had a substantial impact on the development of mathematics and science globally. And second last mathematician is Dattatreya Ramchandra Kaprekar, also known as he was well known for Kaprekar constant, and which is a 6174. So what is the Kaprekar constant and how get this number? So take any 4-digit number in which all digits are not alike. Arrange its digits in descending order and subtract it from it the number formed by arranging the digits in ascending order. If this process is repeated with reminders, ultimately number 6174 is obtained, which then generated itself. Kaprekar discovered the Kaprekar constant or 6174 in 1949. Thus, we see some example. So starting with 1, 2, 3, 4, we have, so 4, 3, 2 minus 1, 1, 2, 3, 4. Here is some mistake, is 4, 3, 2, 1 and then 1, 2, 3 is equal to, so 3, 0, 8, 7. Then again write decreasing order, so 8, 7, 3, 0 minus again increasing order 0, 3, 7, 8, which is equal to 8, 3, 5, 2. Again this number can be write decreasing order 8, 5, 3, 2 and again increasing order 2, 3, 5, 8. So we give 6174. So which is a Kaprekar constants. So repeating from this point onwards leaves the same number. So we can see 7641 minus 1467, which is 6174. And next famous mathematician is Srinivas Ramanujan. Ramanujan was born on 22 December 1887 into a Tamil Brahmi Jainagar family in Eros, in present-day Tamil Nadu. He was one of the India's greatest mathematical geniuses. He made substantial contributions to the analytical theory of numbers and worked on elliptic functions, continued fractions, and infinite series. In January 1913, Ramanujan wrote to G.H. Hardy, having seen a copy of his 1910 books Orders of Infinity. In Ramanujan's letter to Hardy, he introduced himself and his work. Srinivasa Ramanujan's work has found applications in physics and engineering. And G.H. Hardy invited Ramanujans to England. He developed rapidly as a mathematician under the guidance of G.H. Hardy, who brought him to Cambridge University in 1916. He published more than 340 mathematical papers spanning various mathematical areas, and also one film. The film The Man Who Knew Infinity is based on Ramanujan life, and also our government to in 2012 years was celebrated as a National Mathematics Year by the government of India. So next, this is the table of ancient Indian mathematics and their salient contributions. So first one, the details work of mathematician. There is a period and location and their contribution. So Vedic text, these 3000 before common eras or earlier. The contribution is the earliest recorded mathematical knowledge, number system, Pythagorean type triplet, decimal system of naming numbers, and the concept of infinity. Sulbasuta also is Budhana, Astamba, and so on. So the period is 800 to 600 before common era. The contribution is earliest text of geometry, approximate value of the square root of 2 and pi, exact procedure for the constructions and transformations of squares, rectangles, etc. Third one is the Aryabhata. He wrote the Aryabhatiam, and period is this we already see. He is from Bihar, and contribution is consequences algorithm for square root, cube root, place value system, sine table, geometry, quadratic equation, linear indeterminate equation, sum of the squares and cubes of numbers, planetary astronomy, plane and spherical trigonometry. Again, next one, the Varahamihira. Again, the contribution is summary of 5 ancient Siddhantas, sine tables, trigonometries, identities, sine square plus cos square, again the combinatorics, magic squares. Again, Bhaskara I, he also from Gujarat. Expand and contribution is expanded Aryabhata's work on the integer solutions for indeterminate equations, approximate formula for the sine function, planetary astronomy. Next one, Brahmagupta, he also from Rajasthan, and also contributions in rules of arithmetic operations with zeros and negative numbers, algebra that called Bijganita, linear and quadratic indeterminate equation, Pythagorean triplets, formula for the diagonals and area of a cyclic quadrilaterals, notion of arithmetic mean. Also there are Mahavira also in from Karnataka, a comprehensive exclusive textbook on mathematics covering arithmetic, geometry, algebra, counting, the ancient Jain mathematics traditions, permutations and combinations, arithmetic and geometric series, the sum of the squares and cubes of the numbers in arithmetic progressions. Also one mathematician from Maharashtra, this Sripati. He also write Ganita Tilaka, Siddhanta Sekhara, Dikoti Tana, and etc. So on. And period was 1019 to 1063 common era, and he is from Maharashtra. He also contributions in planetary astronomy. So next one is the Bhaskara Charya, also known for Bhaskara II, also known his name Bhaskara II, and wrote Lilavati arithmetic and geometry, Bijganita on algebra, Siddhanta Shiromani on astronomy, and so on. Also period is here mentioned 1114 to 1185 common era. Is also from Vijayawada, Vijayawada, and contributions in canonical text books used all over India. Detailed explanation including Utpatti, that demonstration or proof, addition formula for sign, function, square, permutations and combinations, solutions for indeterminate equations, ideas of calculus, including mean value theorem, planetary astronomy, construction of several instruments, and another one is the Kamblakara. We also written this Siddhanta Tattva Viveka. He also from Uttar Pradesh, Varanasi. Also contribution in addition and subtraction, theorems for the sine and the cosine, sines and cosines of double, triple, etc. are angles. So these some Indian mathematician which contributed in mathematician. So the important thing is that so there are Aryabhattas, Brahmaguptas, and so many Indian mathematicians very crucial role in our Indian mathematician. So here also one thing is that there is a concept of 0 0. Already there are so many Indian mathematicians who find out what is the zero, the notation of zero. But initially in India, Brahmagupta's founded what is the zero, and he defined the rules for the arithmetic operations. Okay, so these are the history, some mathematics in ancient India. Okay, thank you.